Part 1, square root functions. Let's first remember what the A stands for. The A stands for a vertical compression or a vertical stretch or a vertical reflection. Remember, it's a compression if it's a fraction. It is a stretch if the A value is greater than 1, and it is a reflection if the A value is negative. Next, we're going to talk about the H value, and remember H is horizontal and it is always opposite in the equation. And of course, your last one is going to be the K value, which is a vertical movement, and it is not opposite in the equation. Let's go ahead and take a look at example 1. For example 1, if you notice, we have to identify this equation right here based on the graph. And you must have a movement chart because the movement chart will tell you the A value. So let us begin. So what we're going to do is we're going to first identify the vertex, and the vertex is right here at a 4 and a positive 2. So when I go to write the equation, I know it's going to start off by looking like this. Remember the H value is a 4, so I'm going to write the opposite. It's been translated 2 units up, so I know the 2 is going to go on the outside. I also know that the A value is positive because the branch shoots up towards positive infinity. So if you notice, we have an additional point right here, and we have to have that additional point to determine the A value. So what we're going to do is we're going to use the movement from the vertex to find the value of A. So remember, this is our horizontal movement. And remember, this is going to be A times the square root of that horizontal movement, and that's going to give us vertical movement. So to begin, I know the sideways movement is 1, 2, 3, 4. So I went positive in the 4 places in the 4 directions. And remember, these are in increments of 2, so each, make sure you're counting your blocks right. So that's 1, 2, 3, 4 movements from the vertex. So A times the square root of 4 is going to give us the up movement. And if you notice, for the up movement, we only went up 1 place. So this equation right here is going to equal 1. We know the square root of 4. The square root of 4 is 2. So A times 2 equals 1. So A has to equal 1/2. So we know this 1/2 is going to go right here in front of the square root symbol. Take a look here. I've identified the transformations from the parent function. Vertical compression by a factor of 1/2, 4 right and 2 up. Let's talk about domain. Domain and range are really going to be based upon H and K. And remember, H and K was 4, 2. You have to remember that the square root cannot equal a negative number. But a square root can equal 0. So that's what we're going to base our domain on. What would make this value underneath the radical sign a 0? It would be a positive 4. So what's going to happen is we are going to start our domain at the positive 4 right here. And remember, this shoots off forever to positive infinity. And for your range is going to start right here at the 2, which is the K value. And we do include the 2, and that goes to positive infinity. So down here, please make a note that the domain is always going to be the H value to positive infinity, and the range is always going to be the K value to positive infinity. But I'm going to put a little asterisk there because that's going to change if you have a vertical reflection. Take good notes on that. Let's go ahead and take a look at example 2. Here's the equation that matches this graph. So all that we have to do is identify the following right here. Identify the following: HK. HK is positive 2, positive 8. And that 2 is going to go down here. That 8 is going to go down here but watch how I place that. I'm going to come back and talk about that in a second. Let's go back to the transformations. I know that it is a vertical reflection. I know that it is a vertical stretch, and it's 2 places to the right and 8 places up. I'm going to fill that in here. All right, if you notice, I do have my transformations written here. And remember, it is by a factor of 3 for that vertical stretch. The negative comes into play to let me know it was a vertical reflection. Let's talk about domain. Domain is always going to be h to positive infinity for our unit. And then if you notice for the range, the 8 is as high as it gets. So the K value is still part of the range, but the K value is the maximum point, and this graph approaches negative infinity. Let's take a look at the next graph. The next graph is similar to the first one. We have to write the equation. The first thing we need to do is identify HK. The second thing we need to do is work on our movement chart. So if you look at the graph, we know that HK is going to be -3 and +5. Just double checking my work there. That seems to be correct. So if I was going to write the equation, and this time I'm going to write it in function form, I know that it's going to be x plus 3, and then the plus 5 is going to be out on the outside. There's one more thing that I can tell. I know that it's going to be a negative a value because the graph goes down. So I'm going to put a negative out in front, and now I'm going to use this ordered pair to determine what the a value is. So remember, this middle piece is a times the square root of the movement. So if you notice, we went sideways 1 place in the positive direction. So this is going to be 1. So a times the square root of 1 is going to give us 3 places down to reach that other point. And I put -3 because it is down. So the square root of 1 is just 1. So a times 1 equals a -3. A has to equal a -3. And we already knew that it was negative, so I just have to put that 3 there, and that is going to be the answer for that graph. For the last example, I would like for you to please try this on your own. Please pause here, then check your work. So here's the answer. Check through your work, and then that's it for part 1.